Go to year 11 and 12. Here's another A-level question, this time a complex numbers one from summer 2019. I really like it because it uses all three ideas in complex numbers, all three forms, the exponential form, polar form, and rectangular form. So the first thing we're asked to do is to take this complex number given to us by u and get it into exponential form, and then we have to also find the exact values of the modulus and argument of u to the power of 4. So as usual, this is a question where you don't touch your calculator. Right, verify that u is a root of this equation. Now you could do this using rectangular form, and it actually isn't that bad, but when I did it, I used it as a bit of practice at polar form, and that came out very nicely. So we have to verify that u is a root, and we have to state the other complex root of this equation. So this part we can do straight away here, and I'm not going to come back to it, but don't forget it. By the conjugate root theorem, we know that the other root will be u conjugate, which is u star, which is root 3 minus I, is the other root. And we know that because we've got a polynomial with real coefficients. So if we find one root, the other one will be, the conjugate will be another root. Lastly, we've got a locus problem, and we have to shade in complex numbers z that satisfy these inequalities. So this first one is going to be a circle, right, because we're saying the magnitude between z and our point u up here is less than or equal to 2. So it'll be a circle with radius 2. And this bit is very easy, mz greater than or equal to 2. So that means the imaginary part being bigger than 2, so it's going to be a horizontal line where we shade everything above that. So the thinking part in the question really is going to be in here, and just carefully looking at some of the points where that crosses the axes. Okay, so that's a long lead-in because I want all of you to not watch before you try these questions. I also want you to be really careful to note down any places that you're a bit wobbly. If you're doing exponential form and not liking it, Dr. Frost Maths has some good questions, as does the textbook. So going back to part 1, we've got root 3 plus I. So straight away you should see a special triangle sitting there. Here's root 3 and here's 1. So the length of u is going to be 2. The modulus of u will be 2, and the angle will be pi on 6. So u is equal to 2e to the I times pi on 6. So that's that bit done. Now we have to work out u to the power of 4, which is super easy in this form. It's going to be 16e to the I times 2 pi on 3. So I did that so quickly because all we really are doing is our year 9 rules of exponents with slightly more interesting numbers. Okay, so that's all there is to it. We just have to state that the modulus is 16 and the argument is 2 pi on 3. Now be really careful that we've given it how we were asked to give it. We want to have our argument between negative pi and pi, so we're fine. Right, so it's the principal value idea that we've seen all year coming up again. We're measuring this way and this way. Right, so values between negative pi up to pi. Right, let's have a look at the second part. So we're going to verify that u is a root of this polynomial. So let's just start out by saying that p of z is equal to z cubed minus 8z plus 8 root 3. And I'm going to write I'm going to write u in polar form. So u is equal to 2 cis pi on 6. Now you can either substitute directly in, or you can do a little bit of working out to the side, which is what I did. So u to the power of 3 will equal 8 cis 3 pi on 6, which is pi on 2. And that's using de Moivre's theorem. And what about 8z? So now we're ready to put it in. So evaluating the polynomial at u, we get 8 cis pi on 2 minus, what was u? 16 cis pi on 6. Right, just substituting in that, plus 8 root 3. So what's 8 cis pi on 2? Well, that's 8I minus 16. Cos of pi on 6 is root 3 on 2, plus I sine of pi on 6 is 1/2, plus 8 root 3. So we get 8I minus 8 root 3 minus 8I plus 8 root 3, and that equals 0. Therefore, U is a root. Let's go back and see what else we had to do. I think that's about it. Oh, we had to state the other complex root of the equation, but I already did that. That's going to be the conjugate, which is U star. Well, maybe I didn't do that in this version. So U star is equal to root 3 minus I, and that's going to be the other root. Lastly, we have to do the sketch of the locus. So make sure that you take in a compass and a ruler so that you can do a nicely to scale picture, because it really will help you here. I'm going to quickly rule one up so that you can see what I'm talking about. We've got our set of axes. And we're centering, so we want, first part is z minus u less than or equal to 2. So we're going to center it at u, at root 3 plus 1. Which is about like this. I'm doing this on purpose in the video, even though you're sitting there watching and going, God, this is so boring. Things I want you to notice is that we already found the modulus of that complex number. We know that it was exactly 2. So that's really important because it means that my locus is going to go through the origin. Let's just get rid of that ruler. So the circle is going to go through there and there. This point here is root 3, and this is I. So my circle is going to come back here somewhere. And here it's 1 up, so it has to go 1 down to here because the modulus is 2. And here it's going to go up to 3I. So let's pop it in like this. Now you can also see by symmetry that if it's that is there, that angle that is formed there, we're going to have this point here at 2I is also going to be on that locus on the circumference of the circle. So if I draw it in now, oh, that's terrible. But the important thing when you draw that is it needs to go through this point here, and it needs to go through this point here. I'm going to show you a nicely done version in GeoGebra. Now, the last thing we've got to add in is the imaginary part of z has to be greater than or equal to 2, so it's time to get the ruler back. There we go, not too bad. And we want to colour in all of this area in here. Right, don't spend too long on your colouring in, but try and do it like that. In GeoGebra, it looks like this, right? And you can see that going through this point here and this point here is important to show that you've really understood what that locus looks like. Okay, that's all from me for this one. As I said, it's time to make sure that if there's anything there that you're not completely confident with, that you go and do some follow-up exercise work in the textbook or Dr. Frost. Thanks for watching.